Then I'd like to invite Dr. Eddy from Qualcomm, and he's going to talk us about prospect and recent progress towards 6G. So let me introduce him very briefly. He worked at Samsung Electronics, and he also worked for Intel as a 3GPP RAN Prime, and now he is a senior director at Qualcomm, and he's serving as a Next G Alliance Technology Working Group as a chairman. And so let me welcome him, Dr. Kwon.
Hello, everyone. I'm Eddy Kwon from Qualcomm. First of all, I'd like to thank Korean Ministry of Science and ICT and other organizers of 6G Global 2021 for inviting and giving me this wonderful opportunity. I'm so excited to present Qualcomm's view on the 5G advanced and 6G technologies. Let me start with a quick overview of 5G evolution in 3GPP by summarizing key features of each release of 5G systems. The first release of 5G, developed in release 15, presents the 5G NR foundation by supporting fundamental and critical features such as massive MIMO, millimeter wave, advanced channel coding, network slicing, disagreed RAN, service-based architecture, and so on. Then release 16 and 17 expand to new verticals, new deployment scenarios, new use cases, new spectrum, by providing additional features such as NR operation in unlicensed spectrum, URLC optimization, V2X and sidelink support, support of reduced capability devices to address wearables and other IoT use cases, support of spectrum up to 71 GHz, IAB, integrated access backhaul, NTN, non-terrestrial network, positioning support, and so on. Release 18 and onward, formerly called 5G Advanced, are expected to study and enhance the specifications to support longer-term research features such as AIML-based air interface, full duplex, higher millimeter wave, possibly up to around 100 gigahertz, and so on. Now, what is the key drivers or key applications for 5G Advanced and 6G? Qualcomm believe a key application towards 6G is merging of digital, virtual, and physical worlds, also referred to as metaverse. This is essentially ever-present spatial internet complete with personalized multisensory digital experiences that span the physical and the virtual worlds. This vision puts up a lot of challenges to next generation wireless communication systems, not only in terms of traditional KPIs such as throughput, latency, reliability, coverage, system capacity, mobility, and so on, but also a new requirement of intelligent integration or fusion of communications and sensing, positioning, and ranging. In addition, a new device form factor such as AR glasses will highly motivate compute offloading and edge cloud or even cell site cloud due to the constraint of thermal requirement and limited computing power at such devices. To make such a next level of digital experiences reality, Qualcomm see the following the key research vectors. First, AIML powered end-to-end communications is a key enabler for 5G Advanced and 6G to bring intelligence everywhere, on network, on base station, on devices, and so on. This involves the data-driven communication and the network design with joint training, model sharing, and distributed interface across networks and devices. I will elaborate on this in later slides. Then spectrum is always a key component of new generation of 3GPP wireless communication systems to support new applications with more stringent requirement in terms of throughput, capacity, coverage, and so on. New spectrum opportunities for 6G are sub-terahertz or even terahertz, as well as so-called high mid-band, such as spectrum between the 7 and the 24 gigahertz. In addition, spectrum sharing, including dynamic coordination with environmental awareness, will be an important research area. Another critical research area is new radio designs. That is a generally critical advancement for every new generation. So example research areas are evolution of the duplex schemes, larger scale advanced massive MIMO, millimeter wave evolution, reconfigurable intelligent surfaces, non-terrestrial communications, waveform coding, system energy efficiency, and so on. Then, joint communication and sensing will be another key research vector to enable physical, digital, virtual, immersive interactions, taking human augmentation to next level. Scalable network architecture will be another key research vector encompassing disaggregation and virtualization at the connected intelligent edge, use of advanced topologies to address growing demand. Last but not least, communications resiliency becomes increasingly critical. Relative research areas are trust and configurable security, post-quantum security, robust networks tolerant to failures and attacks. Design goals and the performance factors for 6G are given on the bottom. Now, let me talk about a bit more details of several selected research topics. Data-driven end-to-end wireless systems are being actively and extensively investigated in academia as well as industry. It involves distributed cloud, disaggregated network, and edge devices. So example research areas would be essentially intelligence everywhere, the spectrum intelligence, network and system intelligence, for example, network resource management, network energy saving, transmission intelligence, and adaptive baseband processing, such as channel status feedback, non-linear MIMO, beam management, sensor fusion, and so on. Then the AI/ML training and inference scenarios can be classified into three. The first case is training and inference is done at the network only. So potentially with the extension of existing data collection procedures to enable network-based AI/ML use cases. Another case is that training and inference is done at device only, potentially with the extension of existing device implementation of AI/ML to allow the network assistance or configuration of device-based AI/ML procedures. The last scenario is a more advanced one where training and the inference is done at both device and the network, referred to as cross-node ML. So Qualcomm believe the last scenario should be well explored because there are many use cases that will substantially benefit from cross-node ML. Let me conclude the AI/ML part by summarizing the 3PP work with respect to ML-based air interface development. SA has worked on network automation for 5G from the first release. It has developed new enhanced core network functions for data collection and exposure. So recently, SA is studying traffic characteristics of ML, focusing on over-the-top use cases. On the RAN side, we have to work on the data collection from devices for SON and MDT. That stands for self-organizing network and the minimization of the drive test. So recently from release 17, functional framework and the use cases for AI/ML has been studied. From release 18, starting from Q2 of next year, ML-based NR enhancements are expected. So main use cases will be channel status feedback, the beam management, positioning, and so on. Now, let me talk about expected 6G spectrum and the relevant technologies. 5G NR spectrum is sub-7 GHz and the millimeter wave up to 71 GHz as of now. That may be extended up to around 100 GHz in later releases. The sub-terahertz and possibly terahertz will be new 6G spectrum where new foundational design, including waveform and the topology, will unleash the benefit of the terahertz system, such as ultra-high throughput and advanced sensing, possibly with limited range. Another new frequency opportunity for 6G is a spectrum between the 7 and the 24 GHz called FR3 in 3GPP. This spectrum may be able to provide wide area coverage as well as high capacity through larger scale massive MIMO, for example, 10 times more antenna element than the 5G massive MIMO system. Millimeter wave enhancement in the 5G band is also an interesting and important research topic toward improved coverage, latency, robustness, and the power efficiency through enhanced beamforming, beam tracking, and topology, especially based on the learnings from 5G millimeter wave deployment. Another interesting technology is migration of 4G, 5G spectrum to 6G, requiring efficient sharing the techniques. Okay, so the potential 6G radio technologies are listed here. Some of them are already mentioned earlier. So AI native air interface will be a critical enabler, and sub-terahertz and potentially the terahertz will be opportunity for 6G. Millimeter wave evolution, as I mentioned, is an interesting research area, and advanced MIMO, massive MIMO systems, and the spectrum and RAN sharing, and the 5G and 6G migration, as I mentioned earlier, the advanced duplex, including full duplex radio, reconfigurable intelligent surface, especially as a means of the energy efficient communications and cost efficient possibly. And ROS MIMO, such as the OAM, will be a technology to improve the capacity, especially in a line of sight environment, waveform modulation modulation, and multiple access for massive connectivity, massive network and D2D and side link communications. And seamless mobility will continue to be a key requirement, and the UE cooperative communications will possibly improve the capacity and potentially even the coverage. Joint communication sensing, I mentioned earlier. So green network is one of the most important requirement, and the UE power saving, zero energy and passive IoT to address new IoTs on top of the 5G systems, and low resolution communications, especially in the context of the MIMO, decoding, and modulation. Now, let me talk about the physical topology, especially from the perspective of cloud, where the cloud is physically located. In 4G, eMBB and massive IoT are the main applications that are served by regional cloud. 5G expands to more applications such as VTX, URC, XR, and industrial IoT that require local edge on the on-premise enterprise and low latency operator services. In 6G, in order to serve merging of digital, virtual, and physical world, cell-side edge will be required for even lower latency and compute offloading from device to network. 5G has enabled low-cost distributed topologies with heterogeneous node types as illustrated in the figure. For example, small cells, IAB, repeaters, RIS, diversity of radio access technologies such as wireless LAN and roadside unit. So 6G network topology will continue to evolve toward the scalable and sustainable systems and the network. So as I mentioned earlier, communications resiliency is a critical requirement for 6G systems. So key security topics are secure communications against resourceful adversaries, post-quantum security, data security and privacy and identity and device management. Let me conclude today's talk with the following remark. The key research factors that I mentioned today will fuel next generation use cases, networks, and devices, leading to next level of multi-sensory digital experiences anytime and everywhere. Thank you for your listening.
Thank you, Dr. Kwon, and really appreciate your explanation on the standardization timeline and where we should focus on in the technology point of view. Thank you so much.